Hey, I'm Kirk Harnack. On This Week in Radio Tech, we've got Chris Tarr, Chris Tobin, and our special guest, Bill Harland. Bill's going to give us a tour of the ERI factory and tell us about how you put two big honking signals together and do it efficiently. It's on This Week in Radio Tech, coming up next.
Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for This Week in Radio Tech is brought to you by Cachefly at CACHEFLY.com.
This is This Week in Radio Tech, episode 129, recorded May 16th, 2012. Bill Harland. This Week in Radio Tech is brought to you by Axia Audio and the IQ IP Audio Console on the web at axiaaudio.com/IQ. Hi there, it's time for This Week in Radio Tech. I'm Kirk Harnack, your host for the show. I'm just delighted to be here. I'm a broadcast engineer from way back when. See this gray hair? I got most of it fixing transmitters. And Kirk, I ran a broadcast contract engineering firm for quite a few years. I was on the air on some radio stations in Kentucky and in Mississippi and Arkansas. Ran a broadcast engineering firm out of Memphis, Tennessee for some time. And now I work for the folks at Telos, but I'm still part owner of some radio stations in Mississippi and American Samoa. So that's my qualifications or lack thereof. Just kind of been there, done that in small markets myself. Got a guy who's one of our co-hosts, regular co-hosts, and that would be Chris Tobin. He's a big market guy from New York City. Hey, Chris Tobin, thanks for being with us.
Hello, Kirk. Yes, New York City it is. My credentials, pedigree, I guess you can call it. 20-plus years doing radio and some television there as well. And now I'm president at CCS Music Camp for disclosure for IP codecs and audio and video domains. And I, too, have been a crazy radio guy running around in small, medium, and large markets. And enjoying the large market stuff has been fun. So I still do a lot of work with folks on a consulting basis. I still have my fingers in the mix.
And Tom Ray is taking the night off, and that means that the only guy on the show who's actually getting his hands dirty on a daily basis is our friend from Muckwonago, Wisconsin, Chris Tarr. Hey, Chris, how are you?
See, I even have the scrapes on my hand. I can't see it now. Scrapes on my hand to prove it. So, yes, I'm director of engineering for Intercom's radio stations in Madison and Milwaukee, Wisconsin. Still out there every day, beating on transmitters and cranking on phaser cabinets and all that kind of fun stuff. I also do a lot of contract engineering consulting for stations around the area, contributing writer to Radio Guide magazine, and co-founder of broadcastengineering.info.
We got to be sure we mention that website before the show's over again. Remind folks to go there at broadcastengineering.info, right?
Correct.
Okay. The more we say it, maybe the more people will go. I remember every now and then. Hey, and we've got a guest on the show on This Week in Radio Tech. I love it when we have guests because we get to talk to somebody who knows something that we don't. And our guest is a fellow that we talked to at this last NAB show. I was just delighted to meet up with Bill Harland of ERI, Electronics Research Incorporated. Hello there, Bill Harland. How are you?
Thanks for having me on. Have a good evening.
Bill, you're involved with the marketing department at ERI, but you also have enough of a technical background to know what you're talking about, right?
Well, that's actually the case. I've been with ERI for about 10 years, and before that I was with Andrew's Broadcast Products Group. And before that, Broadcast Electronics, and worked for Harris for a while. So I've been pushing transmitters and antennas around for quite some time.
Well, on this show, we're going to talk about a few little topical things here at first, as we often do. But we're going to get around to getting, I guess, a little tour of some of the ERI manufacturing facilities. I think you got some pictures to share with us. And then we're also going to hear something that I was just taken by at the NAB show, and that is this combiner that combines a station's FM signal and a station's HD transmitter, and does so in such a way that you're not losing 90% of the power from the HD transmitter in the form of heat. And this is just a terrific thing, especially for stations that are able to raise their HD power. It's a real boon for radio stations from out at the transmitter side from the technical point of view. Allows them to get more power out or save some money or do both. And I think you've got some great pictures and a diagram too of that system. So, Bill, thanks for joining us. If you'll, you can welcome to jump in any time here. We're going to hit a couple of topical things, and then we're going to jump right into the topic at hand. Hey, guys, last week we had on our show John Poiret talking about engineers and the aging of broadcast engineers, and hey, where are the new ones coming from? Do we need them? Is there going to be a shortage or not? And interestingly, our good friend Mark Persons has written an article in Radio World with the same subject. His title of his article is "Where Have All the Engineers Gone?" And nothing so surprising that he's saying in here. But I was kind of interested in one thing from the article in Radio World. This is from from RadioWorld.com, or you can also go to rwonline.com. He said that recently, this is Mark Persson speaking, he said, recently I was at a cell site that's co-located with an FM broadcast transmitter. I was having trouble with my soldering iron. And I asked the cell site repairman, happened to be there at the same time, if I could borrow his iron. And he said, "Oh, we don't have soldering irons anymore because nothing we work on requires soldering." So I was just kind of curious about soldering irons. I was actually using one a couple days ago. I had to put a PL259 connector on each end of this coax for my new ham radio. Chris Tarr, do you use a soldering iron very often?
All the time. I have about 4 or 5 of them, actually. Funny story. Last week, I was with my engineer from Madison, Tony, and we were working on some stuff, and I wanted to change out a connector. And he said, "Oh, you know what? I don't think I've got a soldering iron." I said, "Hang on." I went out to my trunk where I keep my soldering iron, pulled it out. We were all set to go. So, yeah, I probably have 4 or 5 soldering irons, and almost always have one with me. So you never know when you're going to need it.
I was always enamored with these either the battery powered ones or the little butane gas soldering irons. Do you have one of those?
Yeah, actually, I use the butane one a whole lot. That's really handy to have. They heat up really quickly, and obviously you can get in there and into tight spaces with it without worrying about cords. You know, the one thing I wanted to mention is we're talking about soldering irons. I hear a lot of times people go, "Oh, I can't solder very well," or it's really hard to do. And I have found that, and this was another a guy who mentored me, who really said, you've got to spend some money and get a decent soldering iron. It's the difference between driving a Pinto and driving a Cadillac. And he's right. I mean, I actually went out and spent the money on a decent Weller, even my butane one's a Weller, soldering iron. And, soldering became exceptionally easy after that. It really does. The quality of the soldering iron makes all the difference in the world. And the other thing I would add is the right tip for the job, chisel tip or the pencil tip or whatever. But, if you're going to be doing some soldering, don't buy a $5 soldering iron over at the hobby store. Really get, spend some money. It doesn't have to be a lot. $30, $40 will get you a very high quality portable soldering iron. And life will be a lot easier. Trust me on this one.
Chris, Tobin, in New York City, were you guys solderless, or did you actually pick up an iron from time to time?
Oh, no. Soldering irons were definitely in use. We kept several on the bench, and at the transmitter rooms, we had 1, 2, 3, at least 4. Yeah, you could definitely find them. Because of certain fire codes, we cannot use the butane ones, but we found ways to make the electric ones work just fine in those tight spaces.
Wow, that's amazing. Codes keep you from doing your job well. Because I love those butane things. Indeed, if you were up in some place that's hard to get a cord to, it sure could be valuable, especially if you're like up on a tower and you had to solder something maybe in a strobe light controller.
Oh, yeah. Well, we'll say this, that they've been put in use. It's just they're not officially found anywhere.
Oh, okay.
Because bear in mind, some of the transmitter facilities that I've worked in, the smoke detection systems are part of a larger building, and those larger buildings have connections to the fire department, and you just don't want to, set off that Class C alarm, for no reason.
Yeah, I love. I mean, those butane ones, I love those. I mean, they fire right up. Literally within 60 seconds or so, you're ready to rock. So they're fantastic for those quick, very quick little. I just got to solder this real quick and move on type of jobs. Also, if you have a bench, invest in a variable temp soldering iron again.
Oh yeah.
Weller actually, has a really good package where it's got a portable tip soldering iron that just plugs into the base, which has the adjustable temperature control on it. So you kind of get a 2-for-1 that way. But a soldering station as well with the variable temperature is something else I highly recommend. And again, all of a sudden, soldering becomes real easy to do when you have the right stuff.
I've always found that the best soldering occurs when the tip of the soldering iron is clean. I mean, just slick, silvery, very clean. And am I a bad boy for always cleaning the tip of my soldering iron on my jeans? Because that sure works. It works.
That works really well. I do that. I've got, I do have tinner, and I another thing I always recommend is, unfortunately, it tends to kill your tips fairly quickly. But using the sponge that they give you to keep the tip clean and nice and shiny when you're doing your work, that helps as well. But yeah, either quick wipe on the pants or a fling down on the floor to get it cleaned out, and you're ready to go for another round.
Oh, wow. Hey, I got to ask Bill Harland. I'm thinking about ERI, see, and ERI makes big stuff. Now, maybe they make some little stuff too that I'm not thinking of right now. But I got to think, what's the smallest soldering iron at ERI? 50,000 BTUs. Have you seen a soldering iron out in the shop, Bill?
No, we don't use soldering irons. Everything here is pretty much done with silver solder. So a lot of torches, a lot of butane, and of course, most of what we do is weld.
Yeah. Wow. Well, yeah. In fact, I got to ask about that welding. That's going to be pretty interesting. Especially, ERI makes these beautiful FM antennas, and most folks in broadcast, at least at stations the size that I worked at, are familiar with the ERI, the famous rototiller design. And those things are just so beautifully put together, and so weather, I guess, resistant. I just love the way that they were put together. Such a nice design, and the welding or brazing, and I don't know the right words, but the way they're put together just looked so good. So we'll be asking Bill about that. So, okay, enough about soldering irons. Hey, did you know that today, May 16th, is Salute a High School Radio Station Day? Or it's High School Radio Day. So it's the day to salute them. Apparently, according to an article in RW Online, Pete Bowers is a station manager at WBFH-FM in Bloomfield Hills, Michigan. He pushed the concept about having a high school radio day. He chose May as the month to do it because the first U.S. high school radio station was WNAS. That went on the air in May of 1949. Apparently, there are only about 200 high school radio stations in the U.S. By the way, that includes those stations that don't actually transmit, but they're just they're internet-only streaming operations. And he says that number is dropping. That's kind of hard to believe, but I would think that stations would get into having a studio and streaming. Chris, you guys know anything about high school radio stations and what part they play in promoting our business?
Well, I can say that.
I do know.
Oh, good.
No, go ahead.
Did I cut somebody off? All right, fair enough. I'll go. I participate each year with the IBS folks, Intercollegiate Broadcasting System, here in New York City. They have their annual convention. Folks from all across the country come in, from high schools, colleges, non-coms, the whole bit. And I do know, talking with some of them on a couple of panels, a lot of the high school radio stations that are disappearing, a lot of it is because of lack of interest. Some of it is funding, and those are the two biggies. And the other one is just the difficulty of maintaining the licenses because of the inexperienced people that happen to be fortunate enough to get them and didn't realize what was involved and didn't realize that the license had expired some time ago, and then some FCC person decided to come by and enforce the rule. So that's part of the reasoning. But I think a lot of it probably is the way times have changed, and broadcast industry doesn't have the same luster it had in the past because of the consolidation and changes in programming and imaging.
I think too, you mentioned keeping the license. There used to be the 10-watt educational license that were pretty easy to get for schools, and those have been long gone. And those who have them are grandfathered. But even those, if people forget to renew them or things like that, they go away. And it's a lot harder now because you actually have to license as a Class A, and in a non-com band, you have to kind of wedge it in. And typically, the minute you go away, somebody else jumps in and tries to claim the frequency. So that there's some engineering issues too. It used to be very easy to get one of those 10-watt licenses for your high school. And since those aren't available anymore, they're talking about the LP service, possibly, LPFM kind of, filling in that void a little bit. But I think that was the big one, was it was either upgrade or go away. And if you didn't upgrade, we have a 10 watt here that's just basically been encroached from all sides with other stations on the same frequency. And you can barely pick it up anymore. But I had a lot of fun. I actually did some work for a high school station back late 80s, early 90s. And that was a good time. It was a lot of fun. And the kids back then were still interested in it.
I just wonder, does a high school station can it serve a purpose? Because back in the day, back in the late 70s and all through the 80s, I suppose, I was involved in doing occasional work for high school stations, fixing a console or a transmitter. And that was back before we had Winamp, and back before we had the internet, and back before we had iPods, back before anybody could make their own music programming, if that's what you want to make. And these high school stations that I was familiar with, typically, they did a little bit of talk, but it was mostly spinning records or, punching a button on, next on an automation system. And I just want, is there real value in that? I'm not so sure that there is. Now, if a high school station wants to encourage kids to speak, to talk, to have put together a newscast, put together news stories or vignettes or radio dramas, I think there's value in that. But I can't see any value in just learning how to spin a record or hit next on the automation.
No, I agree, and I think that's the other thing is the lack of programs for some of these school stations. And I've also seen, in some states where public radio takes over and runs a lot of the programming on these student stations too, because they're looking for outlets and it's cheap programming and it's easy to do and things like that. So, it is. It's kind of, I think there's just a perfect storm of things that has kind of made, high school, even college radio to some extent, kind of a disappearing, a vanishing entity because of lack of interest and difficulty in maintaining licenses and things like that.
Remember what Chuck Kelly, who has been a guest on this show a time or two, told us about a non-commercial FM up in Halifax, Nova Scotia, where they program it. It's he wanted to refer to it as push radio, and that may be a good term for it, where basically different content creators, people in the community, would create a show and turn it into an MP3 file, and then upload that file to a little FTP server. And it was really the automation system in the transmitter, and they would just play that out. So you had the community programming without having to have a formal, paying the rent studio location with offices and a phone system and furniture and all that kind of stuff that even a minimal operation tends to have. So you had a virtual radio station that people would upload to. I mean, password protected and all that kind of stuff. That sounded like a pretty cool idea if you wanted to teach, let people learn on their own or teach them how to create content and then let them hear the results of that on a broadcast facility. Doesn't that sound like a good idea?
Yeah, I think it's great.
That would work.
I think it would work, yeah.
All right. Well, hey, let's see. I want to move on to one more thing. Oh, yeah. Chris, you mentioned that the 10-watt educational FMs that are grandfathered in. There is a question of whether or not the FCC should eliminate the LP10 class, the 10-watt LPFMs. Different, I believe, than the 10-watt educationals that are no longer, have been not available for a long time. So this debate is going on. You guys have any opinion or heard much about that?
Yeah, I think it's a good idea. I mean, you look at the difference between 10 watts and 100 watts. You're not talking about a huge difference in coverage, but I think it's I think the coverage is a little more reliable, and I think even 10 watts in a small area is difficult without the proper engineering. If there's I have worked with high school stations that are 10 watts that were designed well, in the mid 70s or whatever when they were still building these, that work fantastically well, but generally not nowadays that kind of experience or expertise isn't available. So these little 10-watt LPFMs, you can barely hear them down the street. So I think it's a good idea.
There's one more topical item I want to ask you guys about. The June 30th EAS cap deadline is approaching. I've got to talk to my business partner at our radio stations. What do I need to have ready by June 30th? Chris, Tarr, I'm sure you've been dealing with cap EAS at your stations. Probably ready, aren't you?
Oh, yeah. No, we've been ready since late last year. There's a couple of ways you can do it. I recommend getting an entirely new EAS box, such as like the Sage Digital Endec, just because the new logging available in these boxes are fantastic. In fact, now I can do paperless logging now with EAS tests, which is great. So that's one way to do it. You can also get the FCC has decided to allow CAP add-ons, which is just basically a single unit box with a network connection that can translate CAP codes into EAS and will work with existing EAS boxes. So there's a couple of ways to do it. Prices range anywhere from, if you just get the CAP converter for EAS is about $1,300 all the way up to $2,500 for a full-on replacement EAS box.
Well, we've got several locations to deal with, so got to talk to my partner Larry about how we're gonna take care of that. He may already have something in the works. Am I correct though in understanding that you've got to have a connection to the public internet at your facility in order to implement CAP EAS?
Correct. You need some form of IP connectivity. Correct.
And if you don't have that, that's just too bad. I mean, you have to make that happen, right?
Yeah, you have to make that happen, and it's getting easier and easier. I know it's going to be kind of difficult for some places, but if you've got internet coming into your studio, you should be able to make it work.
Gotcha. All right. Well, I'd be looking forward to going paperless, man. I could just do without buying any more of those little rolls of thermal paper.
Yeah,
awesome.
We came up with basically we can download the data from our digital Endec into a spreadsheet, and then we already have cover pages already set. I've got an electronic signature, and so all I do is download every week. Tony does, my engineer downloads it every week. I put my digital signature on there. It goes in with a digital public file, and we're done. So it makes logging really, really easy. Although I have found one of the drawbacks is the staff is used to hearing the motor on the printer go to know that there's no alert. They listen to that with the paper coming out, and that's wrong. Yeah, so I have an annunciator panel, and they have to watch for the flashing light now when alert comes in. Otherwise, they won't know it happened because there's no printer on them.
The problem's created by new technology.
Hey, before I forget, there's something I wanted to talk about real quick.
Sure.
A new tool that I'm just all excited about.
Okay.
This is a brand new thing I just happened to find a week ago, and I ordered one. It's made by Hosa Technology. HOSATECH is the website, and they're introducing the CBT 500 cable tester. Now, what gets me geeked out about this is it tests XLR, balanced and unbalanced phone quarter-inch, phono, DIN, Ethernet, USB A to B, and also has test leads on it. And then it has, on the front, LEDs to show you make or break on the connections. And all of this in a portable box. And the price, the street price is, it's like $69.95 is the street price. If you call your vendor, like I did with mine, I got it for $50.
Wow.
And I mean, this thing tests every kind of cable under the sun. It's an ugly-looking box because it's got jacks all the way around it.
Yeah, I'm looking at a picture of it right now at the website.
Right, but I mean, just imagine, how many times you went to go test a cable and you've got your multimeter out with the probes trying to hold it straight while you jiggle to see if there's a short or a bad connection.
Yes.
Yeah, I mean, this thing tests all of that by just plugging it in and shows you lights up whether it's good or bad. And for, if you go through your distributor, it's like $50. How do you not get something like that? I mean, that is fantastic.
Well, what I want is on this Hosa, I don't see an 1 5/8 connector on there, or 3 1/8. That's what I want.
Well, let's VSWR detector on it.
yeah, and a TDM. I don't know TDR. Time to make a reflectometer.
And I want it all for $50.
That's right. So here's the guy that will tell us it's not anywhere near $50. I want to formally bring into the show here and start talking to our guest, Bill Harland at ERI, Electronics Research Incorporated. Bill, hey, listen, thanks for holding on through our topical discussion. Appreciate you being here. And
hey, one of the things I did in college was make my Class D a Class A.
How'd you do that?
Filed a construction permit, did a power increase, bought a transmitter. That's why Harris gave me a job eventually. I bought a Harris transmitter. But that was 1976.
Yeah. So at ERI, you got some pictures you want to go ahead and share with us, and I think that'd be a great idea to get a little tour of the place.
Right. Why don't we just take them in whatever order they appear? Why don't we put up the first one?
And here comes Burke with the first picture. Here he is. Here he comes. There we go.
Oh, well, this is a layout of an aerial photo that highlights some of the areas. We've got here in Chandler, Indiana, which is right outside Evansville, where we're headquartered. We've got about 100 acres at this particular location. A little over 200,000 square feet under roof. Building there on the left is the main manufacturing facility and offices. Besides the office and laboratory space, drafting is located in here, and this is where actually the rototillers are built. And so on the that would be the northeast corner there in the lower right building. That's also where the structural products are constructed, the towers. And then what we call the south building, which is immediately out and back there, is where we've got a burn table. That burn table is capable of cutting, say, a leg flange out of a 4-inch thick piece of steel in a little... it's just great.
Gee.
It's a nice machine. It could hurt you. And we also do the painting out there. And along the back there, there's a raised deck where we actually tune the rototiller and FM panel antennas. We've got a small test range out and back. The center building is where we do purchasing and logistics. Next to that is rigid line fabrication. And then all the way over there on the right, there are two buildings. Those buildings are actually not metal. They're fiberglass. On the building to the that's shown to the north, the top one, that's what we call the Tracer building. And in there is where we actually tune the UHF and VHF television antennas at buildings 120 feet deep and roughly 65 feet across. And the building next to it is what we call the acquired Andrews broadcast antenna business. We took that building down at the Andrew facility outside of Chicago and actually moved it down here. And so that's pretty much the facility. We take whatever slide comes up next. And got a few here that show around. That's just a clean picture of the campus.
I'm really interested in this site here. Yeah, this is amazing, this test range.
Right. We have a full-scale test range. It's one of the largest in the country that's dedicated to FM broadcast use. We've got 70 acres here. It's roughly 5-6 miles from the plant. We've got two turntables, one on the north. This is oriented so that the center turntable there is our main turntable. We can spin towers up to, roughly 14 feet across and 40 feet tall. And then to the south there, this picture is oriented with north to the top of the frame. Then there's a second turntable that's shown there to the south. We also have a static stand there. The buildings there give us some small machine shop capability because they actually do fabricate full-scale models. We really believe that, particularly at FM frequency, you can do chamber testing at UHF because things are small enough. But when you get down to FM, you really have to do things at full scale because when you scale something down to 1/4 its size, you don't need to tweak things very far. Having something bent half an inch out of the way, when you scale that up 4 times, that can really turn into something.
Hey, Bill, if you don't mind, let's go back to that picture that we were showing there just a second, Burke, and let's describe what happens at an antenna test range. And why? I mean, a customer, I guess, is an FM station has a license, a construction permit, and they're going to put up maybe a new tower or maybe put a new antenna on an older tower. And let's say that this station, for all kinds of reasons, that this tower has to be 20 miles out of town. it's not right in the middle of some city of financial interest, or maybe the city of license. Or maybe it's, as so often is the case, the tower is somewhere between the city of license and what I would call the city of financial interest. And we want to, I guess, either we want to optimize the circularity, or the azimuthal circularity of the pattern, or we want to kind of try to make sure that the pattern is going to favor one direction over another. Or another case is where the license calls for you to use a directional FM antenna, and so you guys have to certify and show that this antenna, when mounted properly, will protect this azimuth or that azimuth where another station would exist from too much power from this antenna. So I've described a couple scenarios. Are there others, or have I kind of described why people need to get this tested?
You've covered the primary reasons people pay for either scale or full scale testing. In the case of a directional antenna, you are required to have a proof of performance that can be done at full scale or at partial scale. Both are acceptable to the Commission for the reasons I've stated. ERI really believes that you've got to do that full scale to get an accurate representation, and that's the ERI lambda frequency matched tower sections. Those primary application is as support structures for directional antennas, because as a practical matter, you can't spin and test a 120-foot long 12-bay directional FM antenna. You usually just spin 2 or 4 bays of that antenna. And the thing with a lambda section is it's built to frequency. So all of the structure that supports that antenna through the array is identical behind each element. So if you test 2 bays and then you stack 8 bays for the actual finished antenna, if you use a lambda section, then you know that each section of that antenna is replicated faithfully, and the signal is radiated from all 8 elements in the same fashion because they're reflected from the structure the same. Now, it's important in a non-directional facility to understand that when the Commission talks about, not only for radio but for television, when we talk about non-directional facilities on a side-mounted antenna, the Commission considers that the structure has no impact. But the reality is the structure does have an impact. And not only do we look at optimizing signal or taking advantage of tower reflection, but the more important thing that we often do with pattern optimization, and why you often see directors on an antenna that is not a directional, is the vertically polarized component and the horizontally polarized component reflect differently. And so a lot of times it's very important that you make sure you try and have the same amount of vertically polarized and horizontally polarized signal consistently throughout your desired coverage area, because if you had a lot of V-pole and no H-pole in one area, you're going to have spaces where you're not going to have, where your just signal's going to go away.
Right. Okay. All right. And we're at the moment we've been spending our time talking about the very traditional design of an ERI rototiller design. You guys, as other companies do, you make panel antennas. Can you spend a minute talking about panel antennas and their design, construction, or how you specify a panel antenna?
Well, typically when we look at a panel antenna, the situation is that it's either top-mounted or you have a desire for an omnidirectional pattern on a very large face tower. And you typically want to accommodate, you can multiplex into a side-mounted rototiller 2, 3, or 4 signals without any issue at all. When you get into 5, 6 or more signals, I'm thinking or Senior Road in Houston, you've got 10, the American Tower site in Miami, 11 FM facilities and a common panel antenna. You can also do directional patterns with multiple frequencies using a panel antenna. And a few things, one thing we've done off and on is we'll build a panel system that'll have, say, one station as a directional and everybody else is omnidirectional. So there are a lot of interesting things you can do with panel antennas, but the real thing is Most often, it's multiple stations, solid omnidirectional coverage in a situation where they can't be top-mounted, and lots of power.
Yeah. I suppose at Empire State Building in New York, is there a panel antenna there for the FMs?
Yeah, they're actually ERI has 3 different panel antennas on that facility. The first one, of course, was put up in the early 90s. It now has 17 radio stations on it.
Oh, my goodness.
It's a 2-layer 4-round panel antenna, and then immediately below that, there's the replacement for, I believe it was an Alfred antenna, for the legacy facilities on the Empire State Building. That would be WCBS and WQHT and WPLJ. WKRC also has a port in that. That's also a separate antenna, digital antenna for 2 of the stations that are on the main master antenna. And then there's also at another location a 2-bay 4-round master antenna, which serves as a backup for that single-layer 4-round master antenna.
But Bill, I started out asking about a panel antenna. If I use the word a cavity-backed radiator, is that the same thing as a panel antenna?
Panel antennas have a lot of different configurations. When we talk about a cavity-backed radiator, that typically is an iris basket, and those were very popular. If you remember the old Harris cavity-backed radiator, it's a round basket. Usually the element would sit inside the basket. The benefit of that, Kurt?
Yeah.
The benefit of that is you get good isolation. In other words, you don't get a lot of cross-coupling, mutual coupling between the elements. The disadvantage is the basket does distort the horizontal plane pattern. And so generally, we've gone to a flat screen architecture and then use wings to provide protection from mutual coupling. We just get a lot better pattern circularity that way.
Hey, Burke put up a picture there briefly of some of the Empire State Building. And that's an interesting picture. That's an interesting camera lens right there. So we're looking at, is this Empire State we're looking at right here?
Yes, that's the Empire State Building. The gray antennas there are a couple of ERI UHF television antennas for DTV. This is kind of an old picture, I think. Yes, it is. It's a relatively old picture because you can still see the old VHF batwing antenna at the very top.
At the top,
yeah,
sure.
Hey,
Burke, you had a picture up there previously. Maybe you could put that one on, the one that also included an aircraft in the picture. That one, I think, showed quite a bit of interesting antennas on it, if it's possible to find that one again. What the heck was I gonna? Oh yeah. So we've talked about these panel antennas, which typically are fewer bays, I suppose. But for each bay, you've actually got either 3 or perhaps 4 panels around the outside of a tower,
or a pole. We'll do a top mount, and we'll do a top mount pole. The Senior Road, we've got another one exactly like that one in Oklahoma City. You end up with 3 elements scattered around a 20-inch in diameter pipe. There are wings on that pipe that provide isolation and pattern shaping between the elements, and those are stacked. In the case of both those facilities, you've got 12 bays, so you're actually indexing about 124 feet from the base flange to the top.
So here we have while we have this picture on. Hey, Burke, yeah, there we go. So in the kind of near the upper right, below that ice bridge that goes all the way around, there are some panel antennas. There's some ERIs there. They look like the X or the crosses that are then bent back upon themselves right there.
Right. That's an 1180 series, and that is actually right under the ice shield. The top 2 bays there are the original master FM antenna that went up, was completed in 93. And the one below that is the third element there is actually a separate antenna, and that's what we call the mini master.
Chris Tobin, when you were at CBS Radio until recently, what were you involved with doing anything with those transmitters that fed those antennas?
Oh, absolutely. Yeah, I worked in the, I helped and did some stuff on the overnights in the combiner room, that a very affectionate room that all of us enjoy. And yeah, up at the ice shield and at the base and yeah, I did. We had what? We had three FMs up there that I maintained at CBS, and then over the years, back in 1993, I was also working with some stations there when they were putting up the new master antenna system. So we were on the Alfred, which was the original master antenna. It's a 2-bay. There were little T's. If you're ever up on the Empire State Building, go to the observation deck. Look for the little T's that are at a 90-degree angle, 45-degree angle,
45
off the top of the building, and that's the Alfred antenna.
Actually, you can see them in that picture,
yes.
Burke. If you scroll to the lower left end of that photo of the tower at Empire, scroll as far as you can down and to the left toward the bigger base of that tower. You'll see them. Hey, Chris, while Burke is finding that, let me ask you, Chris, what kind of power would you need to put out of your transmitters, your FM transmitters, in order to get the right amount of ERP, effective radiated power, coming out of those panel antennas?
Well, given the length of the cable, the height of the building, height above terrain, and everything else, everybody's averaging about, if memory serves me right, 8,000 watts, I think, 8,500 watts. It depends on where you are on the transmission lines and losses in the diplexer and stuff. But that's about it, yeah.
Okay, so not super power transmitters, but they got to be reliable transmitters, huh?
Yes, yeah. You definitely want reliable, clean, and you remember you're on a shared network. Think of it that way. It's an RF network. So if you're a dirty neighbor, you're gonna get a lot of people knocking on your door at your transmitter room.
Back to the picture now, and I'm sorry, we'll hit that Alfred antenna now. That's a fascinating thing. Okay, you see in the fat part there, ringing around the fatter part of this tower, you see these T's that come out. They look like two L's that are upside down L's that are back to back right there. There are two levels of that. That's the old Alfred antenna, and it was a special design, I guess, just for this building, and it had a number of FMs, into it. These things were at 45-degree angles to either the vertical or the horizontal, and two rings of them that go around it. The antenna's still there. I guess it's not being used. Is it a backup?
It's actually it can be used as a backup. I think we still have the broadband input still set up to operate. But yeah, it's there because the Empire State Building is a landmark building. You can't take them down. They have to stay there.
One more thing from that picture
for an emergency.
Burke, one more thing from that picture, if you want to zoom out of it just a bit. You can see a single rototiller bay. This is the famous ERI design. If Burke could put that picture back up, I'm sorry we keep asking for it, Burke. I saw, at least in profile there, a single ERI bay, lower left, right above the R in Radio Tech there, Burke. There is a single ERI bay.
That should be gone by now. I think that was Kiss FM's backup way back, a long time ago.
Okay. So just a single backup bay, huh?
Yeah, that bay, that was either Kiss FM or it may have been WNAW. That goes back a long ways. That was their backup in the event the Alfred system failed. That's how they would stay on the air from there. Paid a dear price to have that little guy sticking out there, but it paid itself.
Well, when you Kiss FM, you got to have a little backup, I suppose.
But yeah, it was one of the guys. There were a couple up there over the years, but with the new master antenna, mini master, and the Alfred backup and the reliability, and then since the events over the years, a lot of broadcasters have moved to off-site backups.
Sure.
So years ago, it was not uncommon to have a single stick tower that you had two sets of antennas. One was your primary at the very top or the license height, and then usually a secondary antenna lower down just in the event you have to do maintenance or there was a problem with the primary systems. Over the years, people have realized that's all well and good, except what if and blah, blah, blah. So now everyone's off-site. Buildings down in other parts of Times Square, across the river in New Jersey, or across the river in Queens or the Bronx. So that's how people operate with their backups.
Folks, you are watching or listening to This Week in Radio Tech. It's our 129th episode. I'm Kirk Harnack, along with Chris Tarr in Mukwonago, Wisconsin, Chris Tobin in Manhattan, New York, and Bill Harland, who is our guest from ERI. Our show will continue in just a minute, and Bill is going to get around to telling us about this incredible combiner system to combine an FM and HD, which are just right surrounded around the same center frequency into a single coax and antenna. It's just an amazing technology and a real boon for FM broadcasters. But first, I want to at least mention and tell you about our dear sponsor for this show that helps make it possible, and that is my friends at Axia. At AxiaAudio.com on the web. One of the runaway hit things that Axia has built is this IQ audio console. Now, this is a live wire enabled digital audio console, and the Axia Audio IQ is somewhat modular in terms of panels. The basic console comes with 8 faders and all the meters that you want, and a countdown timer and a real-time clock. That's the IQ console. And on the back of there we go. There's the if you're watching there, you can see the main part of the IQ. By the way, you can take the side panels off, and you can butt several these panels together, these expansion modules, and have a bigger console. We'll speak about the surfaces.
Hopefully Kirk will come back shortly and finish his little repertoire.
Yeah, I got to call him back here.
Okay, fair enough. Well, I will say I have a quick story for an ERI antenna. And many years ago, working on FMX system, I think I mentioned this on many episodes in the past, worked with a consultant who came out to work with us. It was folks from FMX, Brown and Associates out of Detroit, I believe it was. And our facility was Class A. We had a rototiller, a single bay. We believed in just doing a single bay and putting out as much RF as we could. It helped and worked very well for us. So, midnight, we're out there, and the consultant pulls up in his car, former Camden, New Jersey RCA engineer of the day and a former military RF guy, comes out, looks at it, says, "Oh, all right, I see what you got." Takes out a napkin, scribbles a little bit of information, a couple of group delay numbers, and says, "Here's what we're going to expect for bandwidth of that guy. And what's your frequency? 96.7. Okay, we'll be plus or minus number of kilohertz. I think this is where we'll land." And then goes inside, and we had a Continental Electronics transmitter, and he looks at that. He goes, "Oh, I know what the group delay will be through that. Here's a number. Put on the napkin." He hands me the napkin. Says, "All right, kid. I was young at the time. Put this in your pocket, and when we're done the measurements with the HP analyzer, let's pull it out and compare notes." And I kid you not, the numbers were spot on. He said to me, he goes, "Look, these two products, you know where they stand." He goes, "Never an issue. Anybody tells you otherwise, they don't know anything about RF." So I just want to put that out there. All my years working transmitters, antenna systems, working with folks, I have to say every ERI installation has always been what the paperwork says. It's just absolutely amazing. I just had to put that out there.
I've heard that too. Hey, thanks for filling in while my connection dropped, everybody. I really need to finish up the ad because the folks at Axia are paying for it. I appreciate that very much. So look at the different expansion modules you can get for the IQ console. 8 faders, or you can get 6 faders and some button strips to define, to do what you want to do. You can also get 6 faders and a telco module, which will control a couple of different phone systems from Telos, the IQ6, for example, or the new VX voice over IP system. So you can expand this console out. You can also rack mount this console. Each expansion module and the main system are rack mountable. They're 19 inches wide, and they even include the rack ears. You just unscrew them and flip them up and put it in the rack. And then there is the core. That is the part that goes in the rack that has all the audio ins and outs, built-in Ethernet switch. So you don't have to worry about buying a third-party Ethernet switch and getting it programmed correctly. You can use the Ethernet switch that's built right into the core, either the Core 16 or Core 32 portion of the console. And there's a backup power supply. You want redundant power? No problem. Just get the backup supply and stick that right in there. Mic inputs, analog inputs, AES inputs, analog and AES outputs as well, and plus GPIO. It's all built into the IQ console. Check out your favorite dealer in the U.S. The Axia line is represented by Broadcasters General Store, and we have dealers all over the world, plus a number of installers, folks who do system integration will be happy to acquire and install for you an Axia system. On the web, axiaaudio.com/IQ. These things are really cool. Oh, and we got some new consoles, too. We'll tell you about those another time. There's the rack and the desk console, little six-fader consoles. All right. Thanks very much, Axia, for sponsoring this episode of This Week in Radio Tech. All right, Bill Harland, in our time remaining, about 10 or 12, maybe 15 minutes, let's talk about this thing that you showed me at the NAB show. Broadcasters who add HD have a few options for combining the RF output from their HD transmitter along with their FM transmitter. They can do what we call high-level combining, which is when you just, you're shoving these two signals together into the same piece of coax and using a common antenna to transmit both. That's one way to do it. Another way is you can have a separate antenna on the tower to transmit one signal, say the HD signal, so you add a second antenna. Another way is to buy a new transmitter that can actually amplify both signals, the FM and the HD. Most popular way, I think the most popular way, has been this high-level combining, despite the terrible drawback that it's had, and that is that you waste a ton of power from the HD transmitter. Bill, I'll shut up now, and you tell me about this this combiner. It's amazing.
So we've been looking for the Holy Grail. As you mentioned earlier, the problem with combining analog and HD is you've got two signals that are right adjacent to one another. So if you're going to combine two signals that are very, very close in frequency, you can only do that with very, very high insertion loss. Can we bring up that the catalog photo slide, Burke? And so at this year's NAB, we were very fortunate. We've been working on this for about 3 years. We've got the Model 788 all-pass diplexer. This is a production unit. What you're seeing there in the picture is an actual installation at a diplexed system that's used by that's owned by Hubbard Broadcasting in St. Louis, WIL-FM and WXOS, if memory serves. We move to the next slide when you have a chance. This is a very low insertion loss, and as you mentioned, Kirk, with a 10 dB hybrid, you waste 90% of the digital power into a dummy load, and you waste 10% of the analog power. Okay. This allows you, it uses a phase shifting technology rather than a band pass technology, so that what you end up with is instead of losing 10% of the analog power, you only lose 8%. You get 92% of the analog power, leaves this all-pass diplexer and starts up the transmission line to your antenna. Okay. Now, the digital, with a 10 dB hybrid, you end up with a 90% loss. Well, with this, you will end up with less than 30%. So 72% of your digital power goes up the transmission line, starts up the transmission line to the antenna. So this is a situation where if you're on the air now and you're running minus 20 dB CIBOC or 1%, you can take out your 10 dB hybrid, you can put this diplexer in, and you can get to just short of 11 dB down. You can certainly get to the 14 dB that the FCC lets you turn up to without any additional authorization, without buying either a new analog or digital transmitter. So what you pay for this is, besides the losses, is the group delay is a little higher than is ideal, but in the case of the digital, it meets the ubiquity specification. And in the case of the analog, it's highly correctable.
Gotcha. Okay. All right.
And this is not a science project. As I mentioned, the Hubbard's got two of them on the air. This is a production unit.
One of the pictures, I think it was the last link that you sent me, was a diagram. And maybe if Burke could get that diagram, I'd like to understand a bit about what's going on. What are the different components here? I see 4 big cavities in the back, and those are a pretty classic cavity, a band pass type design.
Well, those are actually notch filters. And, the reason we were able to do this is that is what are a pair of what we use at high level for group delay compensation. When you have closely spaced channels on an FM combiner, you end up with the excessive group delay. And what these modules do is, since the group delay is fixed and doesn't change, we can introduce group delay in the opposite direction so it cancels out through the system. Well, so we've always looked at these in terms of the time domain. Well, the other thing you can do with these is if you set them up so that in a group delay mode, you offset tune each pair. In other words, each notch is set slightly apart in frequency. In this application, we make them absolutely identical in terms of notch depth and phase. And so essentially what's going on is each one of the iBox sidebands is going through a 180-degree phase shift. And that's how we're getting the isolation between analog and digital. The digital, each set of cans there, one deals with the upper sideband, one deals with the lower digital sideband. And the analog sees virtually no phase shift. And so that's how we achieve the 40 dB isolation between analog and digital.
And just to point out for our audience, when you take two transmitters, you can't just take their outputs and shove them together. I mean, if you want to put it in terms, here I'll just use this example. A lot of folks know what a CB radio is. Well, you can't if you have two CB radios and one CB radio antenna. You can't just take the outputs of the two CB radios and twist them together or use a T connector and then shove that up to the antenna. No, that's terrible. One will end up blowing up the other. And it'll just be awful. You have to isolate these electrically from each other, even if they're both going to the same antenna. And you do that with a system like what you're showing here that electrically isolates these from each other so that one transmitter, I used the case of a CB radio, but let's say an FM transmitter, it thinks that it's the only guy there. And the other transmitter, let's say the HD transmitter in this case, thinks that it's the only guy there. And neither one of them knows about the other, or it's, 40 dB down, as you said, which is a good quite a bit of isolation. Bill, I'm interested in knowing, looking at the ports here. Okay, I see 3 available ports. In the example picture shown here, they look like 3 1/8 inch EIA flanges. What is each port on this?
All right. Here in the slide on the right, you've got the analog input and digital inputs are shared on that hybrid.
Okay.
And these are each one of these round 4-port tanks is a 3 dB hybrid. Okay. And then the other open port is where the combined analog and digital signals appear.
Okay, so the port on the left, the one that's open, that's where that goes to the antenna. Yeah.
That goes to the antenna. That's where your transmission line would hook up. And the reject load there is rated for about 2.5 kilowatts, and under operation it sees typically less than a kilowatt.
Yeah, so that thing in the lower left is a reject load. Some folks call it a dummy load or a dry load, and it's hooked up to one of those hybrids you can see on the left hand side. So that's the energy that couldn't make it out anywhere else. That's the energy that due to imperfections in the mechanical design of what we have to deal with in the real world, that catches the slop, the overflow, the energy that it just couldn't squeeze into the antenna, because nothing is a perfect system here. Now, in previous systems, though, with a 10 dB combiner or an injector, that dummy load had to be much bigger. Oftentimes they were air-cooled, and they were blowing thousands of watts of heat out of them. In this case, you've got a lot less heat being wasted in that dummy load by a huge factor.
Well, and let's not forget that digital power costs a lot more to make than analog power.
That's true. Yeah.
So
hey,
throwing away 90% of your
So some folks in the chat room were wondering, and maybe you could provide a good explanation. Tell us about group delay. What does that mean in an antenna system? And I don't know, and maybe Chris Tobin or Chris Tarr would like to add to your answer, but help us understand about group delay.
What group delay is all about is as you move away from the center frequency, even in a power amplifier, in a transmitter, or in a bandpass filter, or in a combiner, the elements of the signal actually move slower through that filter system the farther away you get from center frequency. And some work we did at Broadcast Electronics when Jeff Mendenhall was the vice president of engineering there back in the 80s, did some studies to look at group delay. And he improved mathematically and then later in field tests that if you want the absolute best stereo separation, if you want the lowest harmonic distortion, if you want the least amount of noise in the received decoded signal, then what you want to do is you want to make sure that all the components of that composite FM signal arrive at the front end of that receiver as close as possible to the same time as possible.
Yeah.
And what we do with group delay correction, and there's no specification on analog group delay. What we would like to see, ideally you would like to see 15 nanoseconds or less, 75 nanoseconds or less. In practical terms, I'm not aware of any measurements that have showed a reduction in received audio performance at group delay differences of less than 150 nanoseconds. Now, many people could argue with me about that. That's just what research I'm aware of. So you can correct that, as I mentioned, by using a fixed high-level device. We and other companies also make a device that goes between the exciter and the IPA. That essentially all you're doing is just adding reverse group delay, and when it goes through the filter that's causing it, it just all cancels out and becomes zero on the other end.
You know, maybe this is a good way to think about it, maybe not. I like to think of excessive group delay as being, it's likened to distortion, but not in the amplitude domain, but in the time domain. You're actually distorting time the farther you get away from the center carrier, and so that's what group delay is. It's a nonlinearity in terms of time of the signal progressing through a system. And as you said, Jeff Mendenhall showed that you want to minimize this group delay. You want the stereo signal to arrive intact and all in time at the receiver, and you'll get the best stereo separation and the least amount of recovered distortion and so forth.
Absolutely.
Wow. Chris Tobin, is there anything you can add to that about group delay? It's an odd subject to think about time-based distortion.
Not too much. I mean, he's right about the nanos. There was 150 nanoseconds or more. I remember we did the testing years ago with some stuff with the FMX, to refer to that. Group delay was a big to-do. Everything coming to the receiver timed was important. Again, I think that's one of those areas where unless you do a lot of research, it's hard to say how much it impacts. And in today's world with all the digital stuff, it's probably something still to be considered. Because I know in the DTV, the digital television folks, they have to be real careful. I mean, even analog TV had issues with group delay, but now even more so with the digital stuff. I was talking to someone recently, and they just pull their hair out when they find issues with any delay within the RF chain in the system, and it manifests itself into interesting artifacts in the digital world. So I'm sure the FM radio between analog and IBOC and everything else, I'm sure group delay has an effect. But I think with today's transmitters being so linear, so much is given to making sure everything is close, it's probably, one of those things, unless somebody really sits down and dissects it, we probably will never know, where the threshold is.
Bill, we are just about out of time. I want to hit up Chris Tobin and Chris Tarr before we go with any last minute questions. I just want to see, Bill, if you would comment on one more thing. I mentioned earlier in the show about the beautiful manufacturing when you make like the rototiller antennas. That's what I'm most familiar with. A lot of manufacturers put external adjustments on their antennas to fine tune them in the field, and ERI doesn't have this, at least on the outside. You can fine-tune some slugs on the matching section on the input of an antenna. Tell me just a little bit about ERI's philosophy in building antennas. What makes ERI in terms of what comes out the door mechanically as an antenna?
Well, really what we're about is we don't want external feed points. Our feed point is internal, it's pressurized, it's welded. And we don't use adjustable fine matchers. We make them, but in general, we use, as you mentioned, a slug-tuned matching section. And we do that because you only need to match the antenna once when you put it up. And the advantage of the slug is the slugs tend to be broadband devices, fine matchers tend to be narrowband. And other thing is when you're sticking probes in through an outer conductor towards an interconductor, you're reducing the peak voltage handling capability of that. When you use a steatite slug, you're not. And so we believe that you should put up an antenna once, slug it once, and not worry about it. We just replaced one here today, replacing a 33-year-old 4-bay rototiller that had never had a service call.
Wow, 34 years old, and it just stays there and runs. That's pretty amazing, but not exactly unexpected, I suppose.
We try.
Hey, Chris Tarr, if you're still with... Oh, good, he's still with us. I thought Chris might have to leave during the show. Chris, you got any last-minute questions for Bill Harland at ERI?
No, other than I'm real excited to hear about this this new combiner. I am one of the ones, since we went to HD in 04, 05. At that time, that's all you could do at my power level was high-level combining. So I have one of those old wasteful high-level combiners, the injectors. So we are one that and when the FCC came out with the 14 dB increase to minus 14 dB, we couldn't get there because I didn't buy a transmitter big enough. I mean, I have a 3,000-watt digital transmitter, but by the time we get up to the antenna, it's 300 watts after combining. So this is a real good solution for those of us who have spent the money on the infrastructure that's only a few years old and really can't afford to replace. I mean, I'd have to replace a transmitter and a bunch of other things. This sounds like a real nice way to upgrade that without having to spend a whole lot of money.
Chris Tobin, any last-minute comments from you?
Oh, last thing I would say is just check your line pressure, make sure everything's in order, and make sure your VisWire hasn't changed with the weather shifting.
That's always really good advice. Hey, Bill, I'm afraid we're about out of time. If you got any last-minute things you wanted to get in, now's the time to do it.
It's been great hanging out with you guys for the last hour. I've enjoyed it very much. Hope to do it again sometime.
All right. And if folks want to reach you, they can on the web at www.eriinc.com. By the way, that does put two I's in a row, so you're not looking at it funny. ERIINC. And Bill, I guess they can ask for you personally.
They can ask for me or just ask for sales. Everybody's been shown all the ropes on this.
Okay, well, good deal. Well, thanks very much to Chris Tobin in Manhattan, New York, the best-dressed engineer in radio. Appreciate you being here, Chris Tobin.
Oh, you're welcome. Anytime. I enjoy this. This is good. RF is fun. Black magic, but it's fun.
And Chris Tarr, the man who will one day show me all the secrets of geocaching. Chris Tarr from Muckwaga, Wisconsin.
Absolutely. Well, I'm up to I think 115 now after this past weekend. So I will absolutely show you how it all works.
115 geocaches?
Yeah. We went out. We knocked out 7. I think this weekend Nathan and I are going to go for 10. So we're hoping to break 200 this year.
Have you ever put any caches in place, or are you just finding them?
I do. I actually have one called Tower Farming, which is located near a tower farm.
Okay. All righty. Well, I know there's plenty of caches around my neighborhood. I've just got to get out and play that game. I think when my little son grows up a little bit, we'll do more of that.
I tell you what, Bill, that'll be perfect. You'll love it.
I think you will. I've done a little bit of it myself, and I know the thrill of, oh, wow, there it is. There it is. It's a great game. Great hobby. And Bill Harland, thanks again for being with us. I sure appreciate you taking an hour and a half out of your evening to be with us and all the people listening and watching.
Thank you very much.
All right. And thanks to Burke at the TWiT network for switching and taking care of us in terms of production duties. Appreciate you very much, Burke. Our show number 129 here, has been brought to you by Axia Audio and the IQ Audio Console on the web at axiaaudio.com/IQ. Next week, we've got a War Stories episode. You won't want to miss it. We've got quite a thrilling tale prompted by Hurricane Irene. Not something that you'd want to go through, but they did, and we'll have the stories about it coming up next week. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.
Woo!